goes the opposite way. It's named for the direction that it is coming from. So in this case, a northerly wind is coming from the north and it is blowing towards the south. Okay? All righty. All right, so station models. This is an example of a station model. Sometimes they have more information on them than others. It depends on what's happening in the environment. Okay, so in order to keep from writing all these words over and over and over and over, they have designated areas for specific parts of what we can measure with the atmosphere. This particular one, we've got winds that are coming from the northeast, and it's raining. I also know the barometric pressure from the one that's up here. I know that the pressure has fallen 3 millibars in the last 3 hours. I know the temperature from this. I know the dew point from this. I also know that the wind is blowing at 20 knots. Do what? You got it? I know, let's see, my barometric pressure is 1,013.8 millibars. I have thought, oh, and it's also completely overcast. That little symbol up there just told me all of that. That is called a station model. You just don't know how to read it. Not hard. Okay, so this is actually, I think, the second part. We're going to come back and fill in the upper part. So station models show what? They show the current weather conditions of a particular location. Sometimes they have more information than others on them. This one doesn't have any information for visibility. This one doesn't have any information for how much rain has fallen in the last 6 hours. I know it's raining. That's all I know. But like I said, they're kind of hard. It's just a bunch. You've just never read one of these before. Oh, my eyes feel like they're burning now.
Yeah, Miss. Chlorine is not good.
Huh?
Chlorine is not good.
Corn? Chlorine. I think you said corn. I was like, what?
Bleach.
It's not like I poured it in my eyeballs. It's just in the air. Grade everything down. Now we're going to come back and we're going to fill in this part. We're going to start at the bottom and we're going to work counterclockwise. Like the way a hurricane spins.
That was the answer?
What?
Counterclockwise?
I'm not quite sure what you.
That's what a question was.
I don't even know. I haven't gotten there. Are y'all ready to fill in all the different blanks going around the station model? All right. So I'm going to start at the bottom. Okay. There is one that's on your paper that's not on this picture. So I'm going to add it in as I'm walking around this thing, going around this counterclockwise. So at the very bottom, the bottom one, this is showing cloud cover. It's however much of this circle is filled in. This is completely filled in. This is completely overcast. If you draw, it's a pie chart, the very center. You just draw a circle, and you like split it into quarters. If only one of these is filled in, then there's 25% cloud cover. 2 of them would be 50%. 3 of them would be 75%, and completely filled in would be 100%. If it's hollow and it's not filled in, then it's clear outside. If you have a circle inside a circle, there's no wind at all. But that's the very, very center. That's how much cloud cover you have. Now, you guys have another number here. You have 0.50. That is how much rain has happened in the last 6 hours. It's not on this one. So there's another one on your paper, another number down here that's 0.50, or maybe just 0.50. That means that half of an inch has fallen in the last 6 hours. This one doesn't have that on here. Then this one over here in the middle, this is how much the pressure's changed in the last 3 hours. The downward line, or if this has a negative in front of it, means it is falling. So it's gone down 3 millibars in the last 3 hours. If it's a positive here, or if this line is diagonal up instead of down, then the pressure's rising by that many millibars in the last 3 hours. Sometimes the pressure hasn't changed, and that's not there. Then the top right is your pressure. This is in code. I need to teach you how to decode it. But your pressure is in millibars. It's MB. That's its unit. And then this one, this is showing the wind speed. These are called feathers. And then the long bar is called the staff. Now, the staff is pointing in the direction that the wind is coming from. The feathers are telling you how fast the wind is blowing in knots. That is spelled Knots. For this one, it's blowing at 20 knots. Those two feathers tell me that. Each feather represents 10. Half of the feather represents 5. Flag represents 50 knots. It is coming from the northeast. That's the wind direction. Top left is going to be temperature is in Fahrenheit. So it's 76 Fahrenheit outside. In between the temperature and the dew point, if there is precipitation, it will show it here. Not how much is falling, just the fact that it has precipitation. 2 dots mean rain. It looks like an asterisk, like a star. That's snow. It looks like a lightning bolt. That's a thunderstorm. Then all different kinds of symbols can be over here, but it doesn't have to have them. If there's a number over here next to it, that's visibility. That didn't even make it onto the top part of your slide. And then this bottom left-hand number is dew point, and it's also in Fahrenheit. So there's 2 things that can be on here that actually aren't up here. I put the 0.5 down here for rain over 6 hours. The one I did not put up here, and you guys don't have on yours, is if there is a number to the left of this, that is how many miles you can see. That is called visibility. It's just not on this one. I searched and I searched for like 20 minutes trying to find one that had more than this on it, and I gave up. I was like, no. I only have so much time to build an entire week of notes over normally about 12 hours, so I ran out of time. I know that Monday we are doing energy transfer, heat transfer. Tuesday, I am trying my best to get, I don't know where I put it. I had to put all my stuff up because I knew they were about to spray. I have no idea where I put it. There is a word search that I have over insulation. I don't know where it is. I can't find it now. I can't get it to go into PDF form. It's making me very angry. I can't get my computer to understand my printer sending it a scan. I can't get the copier in the workroom to send stuff to my email. I'm getting very frustrated. I have no idea what I did with that paper. I'll have to find it. It is somewhere. Oh, here it is. So I'm trying my best to get this guy to go into PDF form, because I don't want the substitute on Tuesday to have to deal with a bunch of papers. And so I won't be here. I don't know what to do. So moving on forward, the whole purpose of this is it puts a heck of a lot of information in a very short space. We're not running out a bunch of words, but temperature and dew point are going to be in Fahrenheit, because this country, unlike the rest of the world, does their temperature in Fahrenheit. This world does Celsius. Wind direction is coming, the staff is pointing in the direction that it's coming from, not the direction that it's blowing to. And there's little feathers on the end, these shapes that tell us how fast the wind is blowing. Barometric pressure is always going to be a 3-digit number. It's supposed to be a 4 or 5-digit number, but it's a 3-digit number. And I'm going to show you guys how to decode it.
Who taught you this week?
I did. I had, like I've said before, I'm building everything from scratch. It's not hard to go in and figure it out. I did have one of my coworkers from my previous district. They shared their entire ESS drive with me. So I pull a lot of my stuff from there. Some of it doesn't translate very well into Google Slides, and then I have to go and build all that from scratch, but I do have something that I'm going off of. It's looking like we will be reviewing Wednesday, and then we'll have a paper test Thursday, is what it's looking like next week. If I can't get this stupid thing to scan, I may have you work on the review and I'm not here, but we'll still do the commute when I come back. And we'll still test Thursday. I really don't. Like I said, you guys are the easy year this year. This class will be rearranged and will get harder as years go on. As I get more things, more tools that I can teach with, because I don't have very much. And the stuff that I have is not complete. Like my minerals and my rocks, I need to go through them and see what I need to buy new stuff of. I'll print another one off. All right, cloud cover is the circle in the center, the pie graph. I'm going to show you the complete list, and I added a whole bunch of stuff on the canvas for you, so you're not having to draw all the stuff out. If it is open, it's not shaded, it's clear skies. A quarter of it is 25% half filled, like the one I have on the board that they can't see online. That would be 50%. 75% is going to be 3 of the 4 sections filled in, and if it's completely filled in, it's overcast. We have 100% cloud cover, like yesterday when that photograph came through. However much is darkened in, and in this case, because I'm using a white screen, I'm shading it in with black. If it was, there's another one I'm going to show you where the background is dark, and so the shading in is white color. You're using contrast. So however much is filled in. And then there are a few extra ways that we can do this, and I let Miss May's slide show you that. Don't bother me. I don't like to lose stuff.
Have you voted?
No, because I just moved to this county, so I had to totally re-register and I'm waiting for all that to go through. So I would have early voted. I don't want to deal with the polls on election day. I really don't. I don't want to have to stand in line for however many hours. People coughing and sneezing and touching things. Is everybody done with this one? No, I should probably take official attendance and stuff. All right, you guys have this in Canvas because I didn't want you trying to copy this entire thing down. So this station model, the guy on the left, I know it tells you what to do over there on the right. But on the left, it is 28 degrees outside. It is snowing. There's only half a mile of visibility. The dew point's 27 Fahrenheit. The wind is coming out of the southeast at 15 knots. We have had 0.25 inches of accumulation of snow. The pressure is rising 19 millibars over the last 3 hours. My barometric pressure, rule of 500, less, add 10. So my pressure is 1019.6 millibars. And I've got 75% cloud cover. All of that is read off of this. The only thing I really need to teach you how to do is how to decode pressure, because getting from that to this, you're either adding a 9 or a 10, and it's called the rule of 500. Then there's all these different things for precipitation. The type of precipitation is shown here. The amount that has fallen over 6 hours is this number down here in inches. But the precipitation and the visibility are actually on the left. If you see an asterisk, that's snow. If it's a dot, that is rain. If it's a comma, that's like mist or drizzle, just that really, ugh, if you just want to get over done and rain. We don't get smog here, but that's how you show it. Hail, if there's a dot inside of it, it is sleet. This is how they do thunderstorms. If you see a triangle underneath either a dot or a star, then you have a blizzard. In the case of the star, you have a major rainstorm with the dot. We talked about the air masses. You've got 5 of them. They're either continental or they're maritime, and they're either tropical, which is warm, polar, which is cold, or Arctic, which is extremely cold. They even have the fronts on here. Keep in mind, if it's cold, that should be blue. If it's warm, that should be red. Stationary's alternating. They keep their colors, and included they're on the same side, they're purple. This is how they show tornadoes, and this is how we show hurricanes. So this actually does, like everything we've done this week, and throws it into one little picture. They just don't always have a symbol in every single spot. We're going to analyze this one. Once again, temperature's the upper left, dew point's the lower left. I can't remember the order that I put this on here. Remember, if the wind is a specific direction, it's blowing the opposite way. This one does have visibility on it. 2 lines means fog. You only have a half mile of visibility here. The temperature 70 Fahrenheit. We've got 55 Fahrenheit for the dew point. It is blowing out of the east. This is not on the end, so this represents 5 knots. But all of that is read off of this. I didn't put the barometric pressure on this one. I didn't have any accumulation of precipitation on here. I know it's foggy, but none of this is shaded in. The fog is on the ground. That's why we only have half mile visibility. And I don't have a change in barometric pressure going on right now because the air is still or very slowly moving. So, who's not here? There's so many more people that have been put on quarantine. I don't even know who is and is not now. Christian, get people that are going remote. Eastern, EVs in the last year. You do not always have a precipitation code. If there's no precipitation, there's not going to be anything over there. Like I said, an asterisk or a star, that's snow. This is supposed to represent a lightning bolt, so that's a thunderstorm. And you can have sometimes 1 or 2 dots, that's rain. That looks like a comma, that is a drizzle. If it's got a triangle underneath this, then that is a heavy rain shower. You guys have that whole chart. I was not about to make you write down that whole chart. It's not, that's insane. I'm still really curious why all the station models pop off of canvas. There's nothing wrong with that image. If we get governed, do what? Uh-huh. We will do winds next. Winds is the last thing on the front of this page. Winds. Remember, the staff is pointing to the way the wind is coming from. This is representing a northwesterly wind. It's blowing the opposite way, so this would be blowing towards the southeast. And this is not saying that this is a westerly wind. Just keep in mind that the direction that the staff is pointing is the direction the wind is coming from. It's really blowing the other way. And just to be safe, I went ahead and put a compass on here. I heard a couple different acronyms for this. It's never eat soggy waffles was one, and never eat sour watermelon was another. And I've heard some much more inappropriate ones to do cardinal directions. But on paper, up is north, down is south, right is east, and left is west. Let's see, north is really to orient myself. Well, hold on, let me think. So up to front, into right. That is east is this way. East is this way, west is that way, and north is this way, and south is this way. If I just oriented myself right, I don't have a compass on me. Actually, I do on my phone, but I don't pull it out. All right, so wind speed. You guys had images? A circle and a circle. If you have a circle inside that pie chart, you have very little wind at all. They are calm, stationary. If it's less than 5 knots, it's just the staff. It's a line. The line's gonna be pointing in the direction the wind's coming from. If it's 5 knots, then that feather is not on the end and it is shorter. If the feather is on the end and is longer, that represents 10 knots. 2 of these would be 20 knots. Yes.
Accidentally.
You did what?
I accidentally deleted the picture.
Uh-oh. You can't undo it. You won't go, you know the go back button? In Google Docs?
Yeah.
Yes, okay, so I thought it did. 50 knots is a flag, is a triangle on the end. I'm not gonna make you convert between knots and miles per hour. It's like 1.1 mile per hour for every knot, something like that. But we're not gonna go into that. And then just to show you about how things are shaded, I took my friend's, because she uses PowerPoint, I blatantly just stole her slide and stuck it in here. Okay, so like I said, if the feather is not on the end, like this, it is 5 knots. If it is on the end like that, it is 10 knots. If it's a triangle, if it's a flag, then that's 50 knots. Okay, so this is the one I stole from Penny. Her background is dark, which means her shaded areas are white. You have contrast. No clouds is clear. There's nothing in it. Just a circle. I'm not going to put extra lines on yours if I ask you to do this. Lines mean add 10%. So just a line in the center is 10%. And if it's a quarter of the way filled in, that's 25%. I'm not going to worry about this about 40%. Halfway filled in is 50%. I'm not going to worry about that one. Oh my goodness, 3/4 of the way around, 75%. And then completely filled in is overcast. You see an X, it's the same thing as completely overcast.
You guys like the red?
No, yeah, the red ones. I'm not gonna go in and put the extra lines on it. I'm not gonna do that. If Canvas even lets me put the station model in there. I don't know what it had an issue with the one that I put in there.
So the white is the
In
filling.
this case, because the background is dark, the white is the shaded in area. Normally, when I do this on a regular blank screen, it's white, and so the dark is the shaded in area. It's just that the contrast of what the background is the shaded in part. I just wanted to show you this option too. All right, barometric pressure, the only part that well, technically you need to add 10 and 5. I got faith you can add 10 and 5. Barometric pressure on land goes between 960 and 1050 millibars. Now, over the ocean with hurricanes, it can get a lot lower than that. We talked about hurricanes yesterday. The 500 rule, if the number's less than 500, put a 10 in front of those three digits. The number's more than 500, put a 9 in front of those digits. So all you have to do, and then you put a decimal between the last two numbers. Which I think is the next tab. We're going to go through an example of this. It's not hard. Is it above 500 or below 500? Are you adding a 9 or a 10? And then don't forget to don't forget to put a decimal between the last two digits. Once again, 500 rule, if the number's less than 500, add a 10 in the front. If it's more than 500, add a 9 in the front. Please put a decimal between the last two digits. That gets it out of shorthand. Shorthand is only 3 numbers for barometric pressure. Oh, and put MB at the back. That's the unit for pressure, millibar. Barometric pressure always has a decimal, so it's either 4 or 500 small. Anybody still need this one? Okay. All right, you have these. The top one, are you going to put a 9 or a 10 in front of the number? It's less than 500. What do you do?
Put a decimal place.
No, you put a 10. You put a 10 in front, and then you put a decimal between the last two digits. That is shorthand for 1005.3 millibars. The bottom one is when you are above 900, I mean not 900, when you're above 500, and you put a 9 in the front. If it's 964, put in the decimal 2 millibars. It's really not hard. You just had to explain to you how to do it. So above 500, add a 9. Below 500, add a 10. I don't think there's any questions on this. We're going to analyze this guy. First thing it asks us the temperature. What is the temperature on the station model?
45.
45 degrees Fahrenheit. That is correct. Next thing it wants to know is the pressure. What's the pressure?
No.
No, not the pressure. The dew point's 29. The pressure, you are going to put a 10 in front of this, and then a decimal between the 4 and the 5. The pressure is 1004.5 millibars. Next is dew point. Dew point's the 29. It looks like I only gave you guys 1 dot on the side. That's okay. The cloud cover. It is 100% cloudy. It is overcast.
Southeastern.
The wind is moving to the southeast. Well, it's moving from the southeast to the northwest. How fast is it blowing? How many knots?
Does it sing?
It does with the feathers.
Oh, okay. Okay. 18.
15 knots,
Hmm?
15 knots. One long, one short is 10 plus 5. You can add them. And then, are we having any precipitation? What does dot mean? That. What does that mean?
How did you?
It just means rain. It looked like a comma that would be like mist. It had a upside down triangle underneath it, and that would be a storm. It would be a heavy, heavy rainstorm. I don't have the amount of precipitation or the barometric tendency on this one. I also don't have any visibility issues with this one. I said they don't always have everything on now. We talk about isobars, pressure flow, and the difference between convergence and divergence. On a map, if the lines are closer together, you will be experiencing stronger wind. When they are farther apart, you will be experiencing lighter wind. You a lot of times see pressures associated with these. The one I'm going to show you has just a low pressure in it. Energy goes from high pressure to low pressure. Cold fronts to warm fronts. When you have a cold front moving in, like yesterday, we get really windy winds. That's redundant. We get stronger wind when a cold front comes through. High pressure is going to have the air flowing clockwise out from the center in a spiral. Low pressure, which we talked about yesterday, like a hurricane, spins counterclockwise and the air flows in, which is what actually keeps the hurricane together. It wants to stay in. It doesn't want to fly away. It wants to stay in that circular storm as it moves across the ocean. And I just need to do convergence and divergence. I'm going to show you this map first. Okay, so you don't have this on canvas. Here's my warm front. Here's my cold front. We have the occluded front right here. We have low pressure smack dab in the middle. So the lowest pressure on here is 972. Everywhere that line is touching is still 972. And where the lines are closer together, right here, this staff is showing that it's at 40 knots. A little bit further out, it's going down to 30 knots. A little bit further out, that one's 15. But as these things are further apart, this one's only 10. Your wind speed slows down. All right, low pressure masses, warmer air, they want to rise. We call this convergence. We've got, once again, counterclockwise inward motion, which is what helps create the eye wall. Cold air then comes down through the center, and that's the calm of the storm. High pressures are cold. They move faster in general. You have clockwise outward motion, which is called divergence. The cold air sinks. And I have a picture just to show you what these look like, if that helps you. You don't have that on canvas, you can add that to your thing if you want to. We still have about 20 minutes. I am in the process of putting grades in. I did not get sleep last night because I was getting notification after notification after notification, people asking me, can I still turn this in until like 3 o'clock in the morning? Please don't do that to me.
In the morning?
Yes. Don't send me emails at 3 o'clock in the morning. Like, I think I got an hour of sleep last night. Now, if you've had absences, that's one thing. But if you just haven't been doing your stuff, When there are 10 questions, I have like no empathy right now, like zero. If I gave you a paper copy, because I was being nice the other day, I need them today. And I can't remember who I did and did not give them to. You have some. Oh, that's right. What you want? Thank you. Is this all of them?
It's fine.
It's 5 of them. Okay.
That's all the ones I got.
That you got too. Okay. She tried to come back for like, was it the beginning of the same period? And I had a mortgage company on my phone. And at first I thought she was a student. I was like, I can't talk right now. Like, I'm so sorry. All right. So just to show you, this is the difference between convergence and divergence. Low pressures do spin counterclockwise. In. High pressures spin clockwise out. I'm going to go back in case some of you needed that last slide because I'm sure there's some people that didn't quite finish it. Let me freeze this. Let me check online because they may, some minutes would be wise. Let's see here. Oh, I do see more people. Let me stop recording.